Okay, we're going to do the first problem on the practice version of exam 3. Alright, so this is the first question. It's a question about the mean value theorem. Okay, so what does the mean value theorem say? We have an interval here, and we have a function, and the mean value theorem says that if f satisfies certain conditions, then there exists c in the interval from -1 to 1 such that f prime of c is equal to f of 1 minus f prime of 1 divided by, that was completely crazy. When did I say that? f1 minus f of -1 divided by 1 minus -1. Okay, so the existence of this c is what the mean value theorem is saying. Okay, and there's a picture of what's going on here that everybody should be familiar with. So let me turn on my hand steadying device. Is that it? I think it's that one. Okay, so let me draw some axes here. So this function is a cubic, and if we were to plot it, I think it would look something like this. Okay, and we have, what's going on here? Some points that we are interested in. Here's 1, here's -1. Alright, so this is the point on the graph where -1 goes, right? -1 comma f of -1. And this is the point on the graph where 1 goes. So this is 1 comma f of 1. And there's a line that connects these two, which I call the secant line. And what the mean value theorem is saying is that there must be some c in here, so that the tangent line at c, okay, so the tangent line at the point on the graph below c is parallel to the secant line connecting the endpoints of the given interval. Alright, so that's the picture, and it's not really necessary to know the picture to do this problem. So let me try to get rid of all this stuff. I would really like to keep that. So let me see if I can erase this stuff. Right, so now maybe he will move down. There he goes. Alright, so there's nothing complicated about the way you find this c. You know, I've been saying a lot of the second part of Calculus 1 is just take the derivative, set it equal to 0, and solve. Now we're not exactly going to be setting it equal to 0, we're going to be setting it equal to this number, okay, which we'll have to figure out in a second. But first let's take the derivative. So the derivative of this function is f prime of x equals 3x squared plus 1, right? Okay. Now what kind of c do we want? We want a c that satisfies this equation, and now I'd like to know what this number is. So I just plug these values into the function, right, to figure out what this is a number in disguise. So which one is it? It is, this is 2 minus 1 is 1, right? And what happens when I plug in -1? I get -1, -1, -1 is minus 3. So, so I have minus -3. And on the bottom here, the difference between 1 and -1 is just 2. And, alright, so you might recognize this number better as the number 4 divided by 2, aka 2. Okay, so what we want to do here is we want to just find a c so that 3c squared plus 1 is equal to 2. So now if I solve this equation, I'm done. And if you want to leave this as x instead of changing it to c, that's okay. But since I've already written c there, let me go ahead and just solve this. Okay, so now the main event is solving this. So just use regular algebra tricks. So first move, or get rid of this 1, right? Subtract 1 from both sides, and that gives you 3c squared is equal to 1. Okay, now you want to divide both sides by 3. So c squared is equal to 1/3. And the very last thing, let me move myself down a little bit, is to take the square root of both sides, right? So take the square root of both sides and you get c is equal to plus or minus the square root of 1/3. Alright, and you know, frequently when we solve an equation like that, we can throw some solutions away if they're not inside the interval, right? So what was the interval? The interval was -1 to 1. And since 1/3 is a fraction, since 1/3 is a number between 1 and 0, so here's 0, here's 1, you know, 1/3 is right here. If you take its square root, that's another number that's also between 0 and 1. And so, in fact, both of these are inside the interval, so we keep both. So keep both the positive one and the negative one, because both of them lie inside the interval from -1 to 1. Okay, so I love them, I'm keeping them, and that is it. That's all there is to it. One last thing you may or may not want to do is you can rewrite this in a slightly more standard form. It's the same as c equals plus or minus the square root of 3/3. Okay, so I'll put a box around that one. And then if I were a good student, I would actually put my answer here in the box. Okay, so that problem is done. Bye.